All right, so this is week 4, Monday, Q3, Math 7. It is going to be a study guide on functions. All right, so let's take a look over here. So what is a pattern from -14 to -6? What are you doing?
-14 and -6 and adding 8.
Okay, so we're going to add 8, and this is consistent, right? So is it linear? What is it? This is linear, but you have to write an equation, correct? Okay, so if it's +8, you know your slope is going to be 8, right? Okay. So let's see how I kind of forgot how we did this at one point. So let me go back. Um, how do you write the equation? Do you remember how to do that? Mhm. Um, Silas, can you close the door, please? Where the heck is my freaking? All right, so read that question for me one more time, please. What is the linear equation, right? For was -16, 14, and then -6, and then 2? Okay. So we know the difference is 8, correct?
Yeah.
Because if you take a look at the numbers that we did, it's consistent. So it's the change of 8, correct? So yeah, this equation right here, it's not that easy, unfortunately. So first term is -14, right? The common difference is 8, correct? So the equation for this is going to be, you're going to have, did you ever go over this with you guys right here?
No, except for she did.
Is she going to expect you to go ahead and have like piece of paper for you to use for that, or what does she expect you to do with it? Because this is not, I mean, does she expect you to memorize that for the test?
Yeah, she's expecting. So she gave it to us today with the study guide.
That's not really, this is, no, this is not it at all. This is not the equation for that. This one over here is for recursive. The other one is for, this is not the same thing. Freaking garbage. Fucking garbage. Okay, so what I want you to do is I want you to write down the following in your notebook because you're gonna memorize this, okay? Um, ridiculous. Okay, so I want to go back to this. Hold on. I think she's doing it because she doesn't actually know what she's doing, which is not surprising, shocking.
Just asking the students.
I think it's because she literally did not know. That's what every teacher does when they don't know. I've done that before in calculus. But I went back and I went over the answers and then figured it out, and then I went over the next day. Go ask calculus. I don't know what to tell you. Right now I'm busy. Right now I'm also your priority, so go away. So whenever there's linear, okay, like when you have a plus 18 that was -12, was it 12 or 14? 12? 14. 14 to -2, or is it -2?
No, -6.
-6, and then +2, right? So the pattern is +8, correct? And this is consistent, right? So I'm going to put example like this, and you know that you're going from here to here, it's +8, right? And then from here to here, it's +8, correct? So for linear equation, this is your arithmetic sequence. Arithmetic sequence, you want to copy that part down, is a sub n equals a of 1 plus n minus 1 d. Okay, and I'm going to tell you what this means. So kidding me? What the heck is going on here? A of sub 1, this is the first. Okay, what's your first number in the example? -14, so that's your answer right there, right? D is your slope. What was your slope here? +8, right? So we just put 8. So then what we're going to do is we're going to do A sub n equals, when we replace everything, -14 plus n minus 1 d, which is 8, correct? Okay. So then we just need to rewrite this with a little bit of work with math. Okay, so I'm going to distribute the 8 in here and here. Okay. Well, when she asks the kids know what to do. Plus 8n minus 8. Do you see that? Equals. Remember your equation here is like f of x equals mx plus b. Do you see that? You want the x to be the first one. Okay. So we'll rearrange this. So it looks more like this. Can you rearrange that and combine like terms maybe? So some suggestion is combine the like term. Oh, Vivian says that she hopes you feel better and she misses you again today. Yeah, she seems like a really nice girl. Is what? Is that like a goodie but a baddie? Okay. So then this right here is your answer. Do you see that? Okay. So I want to show you what this means, okay? N just means the number. So N equals the number in the sequence. Okay. Do you see that -14 is the first number? This is number 1.
Yeah.
This is number 2. This is number 3, right? So if I were to go ahead and look at this from number 2, right? Which is -6 right here, or is it number 2 in the sequence? I put the 2, this one's saying like n equals 1, n equals 2, n equals 3, right? This equation should automatically tell you what the answer is on each of the n's, okay? So let's say we're talking about n equals 2, right? That number you know is -6, right? But if I were to check this, what I would do is I would do a, why is this not working? Sub 2. Do you see how when n equals 2, it's a sub 2 equals 8 times 2 minus 22. Do you see that? 16 minus 22. What does that equal? -6, right? Isn't that -6 right there? Yeah. So let's say, for example, if n equals 4, like what is the next number here? Do you see that? I would just do a to the 4 equals 8 times 4 minus 22. So what is that going to give you? 10. Do you see how that works? So if I want like n to be like the 100th number in the sequence, then you just plug it in. So I'll do 8 times 100 is 800. 800 minus 22 is 778. Does that make sense? That's how you find it. Do you see that? But you must memorize this part right here. This is for linear. Okay? This is for linear. Okay, you got that? Because like these questions are not really that easy. Like it should take, did you write everything down there? In the thing that you're going to be turning it in? Did you write that down here? Make sure you write down the equation as well, so that way you can turn it in. All right, let's take a look at 2. So here you have 6 and -18, 18 and +54. So what are your, actually, why don't you give me the numbers here? Insert. Okay, what is it? Your homework is right there. You need to start working on that.
6,
Six and then what?
-18,
Okay. What's the next one? What's the next one?
-160.
Okay. Okay. So obviously this doesn't look like it's consistent, right? What's the first one? The first one you could do is -18 minus 6. You can go ahead and do that, correct?
Yeah.
So what is it?
So it's like +24 from 6.
Right, but you're subtracting 24, right?
Yes.
The difference, well, not subtracting, but I'm saying the difference, right? So then let's take a look at the next one. Okay, and then 54 minus -18. So that's 54 plus 18. The difference there is going to give you 72, right? Let's go into the next one. The difference here is a -162 minus 54. The difference is going to be a -206, 216, right? So obviously this is not consistent, right?
Yeah.
So it's not linear, right? We know that. Remember when we went over this, I said generally it is going to be quadratic if you find the difference between the next pattern. Oh, my 10. Great, none of them works. That's awesome. No, I don't think it's my pen. I think I just literally been froze. This is awesome. That's awesome. And I think in one of the other ones we talked about here, I swear we talked about this. Which one did we talk about? When it was we talked about like exponential, there's no pattern, right? But we talked that it was quadratic. I don't know. I'm not sure how the hell I'm gonna explain this. Do this to everything. Okay. So it's not linear, right? We know that. Not freaking pen is not working. It's not linear. But because these numbers are like jumping back and forth and back and forth from small, big, it's probably quadratic, but let's just go ahead and check to see how we're gonna do that. Or exponential, I don't know. All right. Is it linear, exponential? Horrible. You say you finished this, but what did you finish? I don't think you finished it at all. Did you find the answer for this? Then why did you tell me you finished it? Because if you read the instructions, it asks you for the equation. So we're only on number 2, and we're not done at all. Not even close to where we should be. So what are you telling me when you said you're finished with it? What are the numbers? Okay. 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 All right. A linear sequence has a consistent difference between the terms. Do you see how the difference is negative 24, 72, negative 216? This obviously is not an arithmetic sequence, so it's not like the first one, right? Can't do that. The difference is not consistent, so this is not a linear sequence. Exponential sequence, okay? An exponential sequence has a consistent ratio between terms that's like times by 3 or whatever, okay? So negative 18 divided by 6, negative 3. 54 divided by negative 18 equals negative 3. Negative 162 divided by 54 is negative. Okay, so you're dividing each of the numbers from each other. So here, negative 18 divided by 6 is negative 3, right? 54 divided by the next number, negative 3. Negative 162 divided by this, give you this. Are these consistent? It has a consistent ratio. So the ratio is consistent, indicating the exponential sequence has a common ratio of negative 3. Do you see that? Okay. Quadratic. A quadratic sequence will have a consistent second difference. A second difference. I think that's the one when remember we said it was like plus 6, plus 8, plus 10, plus 12. Do you remember that? That's the first pattern. The second pattern between the 6, 8, 10, there's a difference of 2, right? That was quadratic. Do you remember that sort of? Okay. A quadratic sequence will have a consistent second difference. So it's already determined that the sequence is exponential. We don't need to check for quadratic behavior. Since the sequence has a common ratio of negative 3, it is sequential sequence. All right, and then we also want to figure out what is the equation, right? And what is the equation? All right, so this right here is going to be the equation you're going to be using. Okay, this one is geometric, I believe. Let me see. What is the geometric equation versus arithmetic versus recursive? So we need to write this one down. So there's 3 of them, right? There is geometric, recursive, and arithmetic, right? Okay, so write down arithmetic sequence. I'm going to do that the same thing as well. You already wrote down the first one, right? The first one was arithmetic that you already have, correct? Okay, so let's go ahead and do this. Insert. All right. The first one we did is arithmetic. This is the equation for that. Remember, that's the first one we did, right? A sub n, a of 1 plus n minus 1 times d. D is usually the slope, right? A of n is the nth term. A of 1 is the first term, right? D is a common difference. If it's consistent, it's last time we did was it. N is the position of the term in the sequence. Like, is it the 100th number? Is it the second number? Is it the 80th number, right? That's the first one you want to definitely write down. So that will be the first one. Draw. I don't understand why this is not working. This is so frustrating. You know what? It's just not working. Okay, that's the first one. We already have that one now. Next one you should have is geometric sequence. Geometric sequence is the one that you generally use for, this is the one they're going to use for exponential. This is the one we're going to be using for this next one. Okay. Geometric sequence. A geometric sequence is a sequence of number which each term the first is found by multiplying by the fixed number. So either multiplying or dividing. Does that make sense? Multiplying or dividing. Okay. We did find the last one by dividing them, right? Okay. So R is a common ratio, which is gonna be in this case, last one, what was it? Was it a -3, right? Okay. All right. So then and the third one is recursive, but she doesn't need you to do recursive, so we're not gonna even worry about it. So for this sequence, R is gonna be -3. R is gonna be the slope, right? -3. First term, A sub 1, first term is 6, right? So when we plug this in there, I'm gonna go back to this right here. This is your equation, right? I'm not sure if I'm gonna be able to write this one because it seems like, oh, good, I can write it here. All right. You have A sub n equals A1. Well, we know that A1 is 6, correct? R is -3. That was the difference. And the reason how we found the R was, remember, if it's going to be, we know it's not linear, right? But if it's going to be exponential, they will have the same multiplication or division, right? So if I do -18 divided by 6, so that's the second term with the first term, right? It's -3, right? Let's do the third term with the second term. 54 divided by -18, -3, right? -162 divided by 54, -3. Since these are all multiplied and divided, if it's multiplied, then you can check it by dividing it, right? These are the same consistent term, then you know it's going to be exponential, okay? So we've determined that this is exponential, right? So then you use a geometric sequence. If it's linear, you use arithmetic. If it's geometric, you use exponential, you use geometric, right? So A sub n equals A1. A1 is 6, right? Times R. R is -3. You see that? To the n minus 1. Now, you could go ahead and simplify this. Well, technically, you could just leave it like this, really. Yeah, you could just leave it like this. So then, if I were to go, okay, well, what is my next sequence? Like, what is the 10th sequence? What number is it when n equals 10, right? You put A of 10 equals 6 times -3, 10 minus 1. This is going to take a little bit long because you have 6, -3 to the 9th power, right? Well, the reason why this is going to take a long time is because you're going to do -3. This part right here is being -3 times -3 times -3. Da, da, da. You're going to do it 9 times. Do you understand? So it's going to take a while. So, and you can't use a calculator, but if you just write that equation, I think she'll be okay with it. Okay, so she's not asking to find the next equation there. So if I were to do that, -3, this will actually literally give you -19,683. But you need to write that. And if you're going to times it by 6, it's been -118,098. That's a 10th term. Do you understand? She didn't ask you that, but I'm just showing you how this works. But quite frankly, Grayson, if you actually get to telling him that's exponential by showing this work right here, okay? And then doing the work right here and just ending it up with this part right here, you should be good, okay? Because that's your formula. Does that make sense?
Yeah.
Okay, let's go on to the next one. Insert. Okay, what's the next one that you have? What's the next example? Is that number 3?
Yeah.
What is it? No, but what's the number? Uh-huh. Okay. Okay. 21, right? Okay, so the difference with quadratic, remember initially we said arithmetic is going to be either adding or subtracting, and it has to be consistent, right? Actually, I'm just gonna put it. It's gonna be linear. Linear, correct? And for the equation, you're gonna use the arithmetic equation, right? The second one we talked about was if it was exponential, right? You gotta use a geometric equation, right? And this is if you're multiplying or divided by the same number. And it also has to be consistent, right? Okay. So now for quadratic, we went over this a little bit before. For quadratic, the first pattern is inconsistent. Like for example, 2, 4, 6, 8. They're not consistent, right? But the second pattern is the same number or it's consistent. Like for example here, do you see you're just adding 2? Do you see that's the second one, right? Okay. This right here is quadratic. And quadratic, you don't have to do no formula. Because she said you don't have to do the formula, right? All right, so let's take a look at this. So with this one, what are we doing? 6 minus 3, what's the difference? 3, right? 12 minus 6 is 6, right? So far, they're not consistent, right? And next one is 21 minus 12 is, right? These numbers here, this is the first pattern, and they're inconsistent, right? But then if you look a little bit further, between 3 to 6, isn't the difference 3? 9 to 6 is 3, right? These are consistent. So obviously, you know, it is over the quadratic. Does that make sense? But you don't need an equation, so you're good, okay? Because if you're gonna find the equation on this, it's gonna have like an x squared in it. It's gonna take way too long to do it. All right, is there a fourth one?
Yeah, that one I also got called two.
Okay, so let's take a look. Number 4. What's the number that you have?
1.
Uh-huh. Okay. Okay. That's it? 25. This one is, so immediately when I see what this one is, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Do you see that? Yeah. Difference. 4 minus 1 is 3, right? 9 minus 4 is 5, right? 16 minus 9 is 7, right? 25 minus 16 is, I think it's gonna be 9, right? 3, 5, 7, 9, right? So these are inconsistent, right? So you know it's not linear, and you also know that it's not or exponential, because exponential is if you're multiplying and dividing, but they are the same numbers, right? But let's try to see the second pattern. The difference here is a 2. Between 5 and 7, the difference is a 2. 7 and 9, the difference is a 2, right? So the second pattern is consistent, right? So this is going to be quadratic, and you don't need to go ahead and do that, okay? But you see how you're going to show the work here? Did you show the work for that? I'm going to pause this. So you can. All right, let's go on to number 5. What does number 5 say?
Write the minimum number of terms needed to determine whether a pattern is linear, exponential, or quadratic. Write 3 different patterns where the first 2 terms of the same represent a different type of pattern. These patterns should illustrate your answer.
Okay, so we're gonna go over here. Read the first part for me. What is
the minimum of terms?
I think it's 4. Okay.
It's to determine whether the a pattern is linear,
Uh-huh.
exponential, or quadratic.
You need to be doing this on your own next time. You can be Googling this yourself, right? This is what it says. Linear, you need a minimum of 3. You need at least 3 terms to check for constant difference between the consecutive terms, right? And that's when you're subtracting them, right? So 3. So write down linear pattern needs 3. She said she wants to do the work on a separate piece of paper, didn't she? Or, I mean, you can write it here and then just transfer. I don't know what she wants. But quadratic, you need 4. So just remember 3, 3, and then 4, okay?
Okay, I got it down.
What did you write down? Okay, and then she wanted to come up with, what was the question again?
Write 3 different patterns for the first 2 terms.
But she wants one for each type of pattern, as in like one for linear, one for quadratic, and one for other one. Is that what she wants? Okay. So for something like this, you can also do this on your own. Do you agree with me? Okay, so I shouldn't have to do this off with you, correct? You could be doing this, right? All right, so then let's take a look at that then. Because I'm sure like other people, they're doing this on their own, right? Okay, provide an example of a linear sequence with 4 numbers. Is it 4 numbers?
No, 2.
Why 2? And the first, what did she say? The first numbers have to be the same? I know. Well, the first 2 numbers are the same. Okay, so right there, write 3 different patterns. Read that for me, please. Write 3 different what? Patterns. Where?
First 2
2 terms,
are the same,
the same,
but
but,
is
uh-huh. I don't know what the hell that means. Okay, let's do this one. Your linear pattern could be 3, 7, 11, 15, 19. Do you see that? That could be your linear pattern. So let's use that one for the linear pattern. So that will be your linear. Find it. So this will be your linear, correct? Your linear pattern is your arithmetic sequence, correct? So write that pattern down. And then what I want you to do is, what is the difference here? The difference is 7 minus 3 is 4. Do you see that? Keep it going. What is the pattern here? 11 minus 7 is 4. 15 minus 11 is 4, right? 19 minus one number equals 4. The next number here will have to be 23, right?
this is a complicated.
Yeah, you have to create the example. Does that make sense? So, and just with this one, make sure you have the word linear arithmetic sequence. Okay.
Mhm.
And we're going to practice by finding the equation. Okay. Your equation has to be arithmetic. So A of n equals what? Do you remember what it was? A sub 1 plus n minus 1 times d. You got to memorize that. Okay. Remember, your n is going to be like your x for the slope. Okay. So what's the first number in your term, your sequence? First number.
Um,
So 3 goes right there, right? Plus n minus 1. What is your slope here? 4, positive 4. So we put 4 right here, correct? And then we distribute it. Do you remember us doing that? Distribute the 4 into the parenthesis. You have 3 plus 4n minus 4, right? And we're going to rewrite it. So you have a of n equals 4n minus 1. And this is your equation for that pattern. Do you see that? So if I want to do something like, well, what's a 10th pattern? So the 10th sequence means n equals 10, right? 4 times 10 is 40. 40 minus 1 will be 39. That'll be your 10th number. Does that make sense? So that's the first one. So make sure you copy that part down. That is the example for arithmetic or linear pattern, okay?
Yeah.
Tell me what you know about exponential pattern. Well, actually, I'll give you a second for you to copy this part down. All right, so for exponential, let's see. I don't like that one. Did you create one on your own? With whole numbers. I don't like the one that we have there because then it has fraction, like you're multiplying and dividing by 7 over 2 or 3, right? So I don't like that. And the reason I don't like that is because it's in fractions, right? But we could use this one here. Okay. So here's your pattern for this one here. Do you see it? Okay. So just write 2, 6, 18, 54, 162. Remember with this one, exponential, it's either multiplied or divided by a constant number, like consistent number, right? So the way we check is, remember, you do it by 2s, right? Well, you're going from 2 to 6, so it's obviously be division because 6 divided by 2 is 3, right? 18 to 16. 18 divided by 6 is also 3, right? Okay. 54 divided by 18, it is also 3, right? So we know that the constant here is 3, right? Your equation for this, remember this is geometric, right? Your geometric equation is a sub n equals, was it a1, what was it? I forgot. Was it n minus 1? It's a times r to the n minus 1 times, you gotta memorize this. Wait, my pen works. What the hell is wrong with this stupid thing? Why is it not working? That's great. It works over here, but it doesn't work over here where I actually need it. Times r to the n minus 1, correct? Freaking garbage. Right? R is going to be, I mean, before here, the D was like your slope, right? Here, the R is kind of like your slope. Okay, so let's go ahead and do this. A sub n equals, what's the first term?
Okay.
first number in the pattern?
Oh, 2.
2. R, we said was 3, right? To the n minus 1. And this is your equation. You could just leave it like this. Does that make sense? This is your equation. So if I were to go ahead and go, what about the 10th? Or actually 10th will be a little bit too big, but maybe like, because this is 1, 2, 3, 4, 5 term, right? What about the 6th term? Which is n equals 6, right? A sub 6 equals 2 times 3. 6 minus 1 is the 5th power, right? So that's 2 times 3 times 3 times 3 times 3 times 3, 5 times, right? Which will give you 243 times 2 is going to give you 486. So that will be the next number after 162. Does that make sense?
Yeah.
And you can kind of sometimes tell, like when the pattern is 2, 6, 18, 54, it's going from small to big very quickly, right?
Yeah.
So it's going to be exponential, okay?
Where did you get the 6th term from?
I just said if it asks you like what is a 6th term, like what is the next number after that? This is the first term, second, third, fourth, fifth, right? If they ask you for the 6th term, you have this equation to help you with that. Does that make sense? All right. All right, quadratic. We don't need to have a formula for this one. We just need to have, remember with quadratic, the first pattern is always different. It's usually like either even or odd. Have you noticed that? Like usually is like 2, 4, 6, 8, because then the difference here is 2 for the second pattern, right?
Yeah.
Or it might do 3, 5, 7, 9, 11, because the difference here is still 2. Do you see that for the second pattern?
Yeah.
Do you see that? So we can just make something, Grayson. I mean, I could start off with like just 1, right? 1 plus 3 is 4, correct? 4 plus 5 is going to give me 9, correct? 9 plus 7 is going to be 16, right? 16 plus, I forgot. 1 plus 3, 4 plus 5, 9 plus 7. 16 plus 9 is 25, right? 25 plus 11 is 36, correct? Okay. This is easy because you know the difference after this. You know, it's plus 3, 5, 7, 9, 11. Second difference is 2, 2, 2, 2, right?
Yeah.
With quadratics, you can always do this as well. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Do you see that? Okay, so this one's pretty easy. And that's it. That's all you need to have. That's it. You should know that the next number, what do you think the next number is going to be? You don't even need to have an equation for this one.
38.
38.
Oh.
5 squared is 25. 6 squared is 36. What's 7 squared? That's the next one. What's the next one after 49? Did you see that now? This one's going to be the same for the entire thing. The linear and exponential patterns, they're going to be different, but quadratic ones are generally the same. Okay. All right. So we're done with that one. What's the next one? Number 6?
Yeah.
What does it say?
Problem 6 and 17. Which variable would so
Did she even talk about discrete or continuous? When? I've never even seen the examples that you went over, like with a homework that had discrete or continuous.
she did today, but she made it in like a very I couldn't understand, but somehow other people could understand. She gave us this. This is the formula for it, but I'm not necessarily sure if that's supposed to help us with it.
So if you're not sure, you need to go onto this website and then figure it out yourself or watch YouTube videos. What is the difference between discrete and continuous with examples? You need to do this on your own. Discrete data consist of separate values. These values are countable and often represent, that doesn't make any sense. So the examples are like 20, 21, 22. You can't have 20.5 students. Okay, that makes sense. Discrete, it has to be whole numbers, okay? Can't have 20.5 students. That makes sense, right? Okay. Discrete functions it looks like a linear, okay? An output to each infinite countable sets of inputs. For example, a function of f of n 2n plus 3, where n is a whole number, the function is only defined by discrete. Okay. Continuous can take any value within a given range. These values are uncountable and can represent measurement that, okay. Height can be a discrete number or a continuous number. Because with height, you're not everybody's gonna be a perfect 5 foot, right? You could be 5 foot and 1 inch, 5 foot and 2 inch, right? You could be a half an inch, right? So key difference. Discrete involve distinct countable values. Continuous involves a range of values that are okay, so you could technically do like decimals, I feel like, with continuous, okay? Discrete data is often represented in bar graphs, while continuous is represented in line graph or curve. And that makes sense because bar graphs, it's just linear with bars, right? Okay, that makes sense. All right. So you might want to write a little bit of this in your notebooks so you know the difference between discrete and continuous. We need more examples of. So number 6, it will be discrete, mainly because if you're going to be charged like 20 cents for one text, then for 100 texts, it's just 20 cents times 100, right?
Yeah.
Which is $20, right? You drive at a rate of R miles per hour for X hours. Although I don't know. You put dependent, independent. Did you talk about dependent, independent? Well, let's go ahead and check. Okay, so if you're not sure, let's go. Why don't you use this? I don't understand. Why don't you check your work? Why am I doing this for you? Read the question for me for number 6. Yes, go ahead.
X amount of dollars.
Uh-huh.
60 cents.
It's discrete. Your cell phone bill for text is based on the number of texts you sent, which is countable quantity. So if you send 10 texts, it's 10, right? Each text message represents a distinct separate event that you can count. 1 text, 2 texts, 3 texts. Consequently, the amount charged is also discrete because it changes in a fixed increment based on the number of texts sent, right? Okay, so that's discrete. Did you write discrete? Okay, so then the next one, what's the next scenario? What is it?
You drive at a rate
Uh-huh.
of R miles per hour.
R miles per hour
for X hours.
for X hours. In this scenario, describe involve discrete and continuous aspect, but the primary focus is continuous. It's continuous because the time you drive X hours and the rate R miles are considered continuous variables. You can drive for 1 hour or you can drive for 1.5 hours, right? For your text, you can't send 1.5 texts. You can't send 1.5 texts. Does that make sense? It's either 1 text or 2 texts, right? But when you're driving with X hours, you can drive 1.25 hours, which is 60 minutes plus 15 minutes, right?
Yeah.
Okay. the speed, time of speed can take values within range, not limit to whole numbers. So you can drive 1.5 hours at the rate of 60.5 miles, right? Like when I'm driving from here to your school, that's continuous. It doesn't have to be from here to Clayton, it has to be 5 miles. That's not the case. It could be 5.2 miles, right? Okay, so there is the hours that's continuous and the distance is continuous. Okay, text is discrete. It's either one text or two text. Okay, like for example, the number of boys and girls, right? That's also discrete, right? You can't have 2.5 boys, right? It's either 2 girls or 2 boys or 3 boys, right? Okay. All right, so let's go back here so we can write a little bit more about the differences. So this one, the cell phone is discrete because you either have one text, two text, right? No 1.5 text, right? Okay. Next one. The driving of miles per hour. This is continuous. Okay. You can have 1.25 hours, correct? Or you can drive 1.05 miles, right?
Yeah.
So if discrete, no decimals, right? Continuous, decimals are okay, right? Examples, okay? If it's discrete, number of boys and girls, you cannot have 1.5 girls. Does that make sense?
Yeah.
Okay, so yeah. All right, let's finish the last part. What's the last part here? Number 8.
Yeah.
What does it say?
When using the following input output relationships.
Okay, this is easy. You hopefully you'll do really well on this one because it should be easy. Remember we talked about function. It's the vertical line test, right? The x does not repeat, right? So function, you have to pass the vertical line test, right? X for the domain doesn't repeat, right? So looking over here, 2, 3, -2, -3. So is it a function? Yes, function. Make sure, don't just put yes, put yes, it's a function. Because x value does not repeat. That's your answer. Does that make sense?
B, I was
Okay. I don't even know why she even write this down. This is an absolute value. Absolute value looks like this. This is what it looks like. Do you see that?
Yeah.
So if I were to use the vertical line test, if I draw a line here, how many times does it touch the graph?
Once.
Draw another line. How many times does it touch the graph? How many times now? So is it ever going to touch it more than once? So it's yes. Don't put no. No what? No as I didn't pass a vertical line test, or no, it's not a function. It's a function because I don't like to put it. I'll just put because f of x equals absolute value of x plus 1 passes the vertical line test. You can explain it that way, okay? It passes the, what is it?
And it's a vertical, not linear.
Okay, vertical line test, yeah, yeah. But make sure you draw some lines there to show that you actually did it, okay? All right, sounds good. Let me just give you some more examples, okay?
Yeah.
absolute value is gonna be like this plus 2. It's in the shape of a V, right? That will pass the line, the vertical line, okay? If you have quadratic, which will give you a parabola, so you have x squared plus 1. It'll be like this. Do you see that? That will also pass the vertical line test, okay? So just be careful of that. Okay, number 9, read it please. Good, f of -10. What it's saying is when x equals -10, what is y is what it's asking you, okay? So f of -10, explain what you did.
-30, so negative.
Good. So this one is f of t equals is a 5 to the t minus 2. So that's an exponent. You gotta be careful with that. That's like an exponential function, right? So when f is 5 equals 5, this top part right here, just be careful. It's 5 minus 2. Do you see that? Which is 5 to the positive 3, which is, how do you get it?
Okay, so then that's 5 times 5 times 5, which is 125.
Good, that's your answer. All right, next one, number 11.
If dx is equals
You need to show the work here. Where's your work here? 3 plus 5 squared over 4 times 5 plus 1. Show me the work. Okay, so explain what you did.
Okay, so what I did was I replaced all the x's 5. So then 3 plus 5 squared is 28. And 4 times 5 plus 1 is 21. Then I simplify it, which gives me 4 thirds.
4/3. Good. That looks good. Good. Did you put a decimal? Oh.
Yeah.
Okay. So 2 times -2.4, right? Plus -2.4 to the third power over -3 times -2.4. You gotta be careful with the exponents here. Is that 2 plus 2 at the very denominator? Is that plus 2?
It's plus 1, and I'm not sure what this is on the top.
Sorry, I'm gonna look at this.
She didn't like explain what that little comma thing or that.
Oh no, that comma thing is just saying this is a function, comma, find the.
Oh, I thought it was like.
Okay, gotta be careful with this one. Remember when we go over this? This is from a while back. When you have a negative number to an even power, right? Like 2, 4, 6, 8. Your answer, positive, right? If you have a negative number to an odd power, your answer is negative. This right here is gonna be a negative answer. Do you understand?
Yeah.
The negative. What did you get? Did you do 2.4 times 2.4 times 2.4? It's gonna be negative 13.284. I'm just gonna give that to you right now, but you're gonna have to practice doing that, okay? This part right here, that's gonna give you a negative 4.8, right? I don't even know how the hell she expects you to do this. This is bullshit. I'm just gonna use a calculator. Minus, where the hell is my calculator?
I got it.
Did she give you the answer?
Yeah, I got it. She showed me how to like do it. Confusing again. And then she
18.084, so that's gonna be a negative, because it's a negative plus a negative, right?
Yeah.
18.084, that's the top. On the bottom, this part right here, negative times a negative is gonna be a positive 7.2, okay?
Yeah.
Plus 1 is a positive 8.2, okay? And they're gonna divide that shit, which is ridiculous.
So when she went over it with me, though, she was like, she knew how to explain it, but she kept stuttering. Crap.
So your answer is a negative 2.205. This is your answer. So just write that down. But you're gonna have to practice that. Do you think you're gonna be doing this tomorrow in class? But that's your answer.
Because he just gave us like the decimal today, so.
So does she expect you to, like, what are you gonna do tomorrow? Do you have to turn that in tomorrow? You don't have to turn it in. Okay, well, that's your answer. So you're gonna have to figure out how to get that answer, but that's the answer. Okay, that's gonna be on you.
Like tomorrow she's like going over it.
Okay, did you copy everything that I wrote down here? Did you really? Did you have the answer right here? Okay. All right, describe the domain range of each relationship below. Use correct symbol. Input is not range. Input is X. Output is Y. You wrote this incorrectly. Do you understand? Your domain is 2, -1, 5, -7. You didn't write it down. 5, 3, 1, -1. You don't just label it. You should know how to do this. Why didn't you show the work for this? And for number 15, what is that? Is it the domain or is that the range? It says describe the domain and range. The first thing you have to be doing is writing down the word domain and range. Because what is this? Is that the domain or is that the range? How the heck would I know? Can we put a little bit of effort and like tact into this? For number 14, label it. You didn't write anything down. You just not know how to do that one. You say you did everything that you know how to do. You're telling me you don't know how to do that? This is the easiest part of the whole thing. What is your domain for number 15? And what? Did you write that or did you write that? I mean, do you understand what you wrote? Look at the graph here. Your graph should be negative infinity to positive infinity. Because when this graph keeps going down this way, it's going to get bigger and bigger. Do you see that? Does it have arrows or not have arrows? Because that matters. If it didn't have arrows and it just had like points like this, then that means it stops right there at -3. But did it have an arrow or does it not have arrows? If it had arrows, it's negative infinity to positive infinity. Do you understand that? If it's a dot, then it's just -3, comma, 5 with brackets. Or you could put -3,
Okay,
saying that X is going to be between -3 and positive 5.
and it's as similar as the arrows as in like it's going around the entire.
No, that doesn't make any sense to me. Arrow implies it's going to keep going down. Does that make sense? Don't draw the arrow because it doesn't make any sense mathematically. Range, top and bottom. So does it have arrow or no arrows?
It had no dot or no arrows.
Who drew this? Can you erase that so I see what it actually looks like without you drawing over it? Let me see that. There are dots right there. Do you see the dots right there? If you
I thought.
Well, if there is no arrow, you assume there's a dot. Because that's where it's ending. Do you understand? Range. How low does it go? How high does it go? How low does it go on the y value? On the y-axis? Show me where the graph starts on the y-axis. That says 0. There you go. How far does it go up? Is it 8 or 9? I don't know what it is. That's your range. Or you can put 0, less than or equal to x, less than or equal to 8. That concludes it. There's a lot on this. You need to study for this.